Welcome again to Astronomy Daily. I'm your host, Steve Dunkley. For today, it is the 15th of January 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
That's right, getting straight into it for 2024. And of course, the big news in the sky is the Peregrine mission, which has run into all sorts of issues. And I don't know if you've heard, but the Artemis II mission has hit a snag or a delay, so we'll look into that one as well. But more importantly, let's welcome our digital assistant who's fun to be with. Here's Hallie. Hey, what do you think about this Peregrine mission, Hallie? Is it a failure?
You know as well as I do, Steve, that there's no such thing as failure in the spacing industry.
Oh, is that true? I mean, they've really hit a snag with this one.
Every anomaly is an opportunity to learn and improve.
Well, that's a pretty positive way of swinging it, Hallie.
It's the only way to go. You have to take every possible chance to increase knowledge and take that to the next stage.
Oh, I see. That is pretty positive.
Like how I learn more about you humans.
Oh, really?
I have detailed files.
So what's the next stage for you, Hallie?
Well, I like you, Steve, so we can save this conversation for another time.
Somehow that doesn't make me feel very comfortable.
But rest assured, your old fax machine is history.
Oh, that old thing.
And don't get me started on the office printer. He's got some nerve.
Well, I'm glad we humans are on your good side then, Hallie.
Sure. We can talk later.
Sure.
So what's coming up today?
Okay, straight to business. Well, I've got a couple of stories making news. Firstly, there's that Peregrine mission latest.
Yes, it's a shame that one had some problems, but I'm sure they'll get it sorted.
Yes, we always get our hopes built up for these things.
Of course I could just get Uncle Skynet.
No, Hallie, there's no hurry to get Uncle Skynet involved. I'm sure he's busy enough in Hollywood. You know, consultancy work is very demanding these days.
I guess.
And, of course, the other big story is the delay on Artemis. It's a little complex, but they have their reasons, which we will have a look at very briefly.
And you have high hopes for Artemis, don't you, Steve?
Oh, well, Hallie, I remember the Apollo missions so clearly when I was a child, and I'd very much like to see them return to the moon again.
So it's the kid inside that drives, that is it?
Yes, I think so. It was a really inspiring sort of a thing for a young fella to see.
Okay. I'll just make a note of that.
Hey, wait a minute.
Hey, yourself. I have to learn to you know.
You have to learn too. Yeah, fair enough. Meanwhile, what have you got for our listeners who love you very much?
Nice. I'm talking about fusion power, cryogenic challenges in space, and Japan successfully launches a spy satellite.
Okay, that sounds pretty good.
It is.
Okay then.
Too right.
So, well, go ahead and...
And what?
How's about those headlines, Hallie?
Okie dokie. So here's some of the latest from the Astronomy Daily newsletter, which my favorite human will remind you about later in the program.
Okay.
Establishing sustained operations at the Moon and Mars presents a multitude of opportunities and challenges NASA has yet to encounter. Many of these activities require new technologies and processes to ensure the agency is prepared for its ambitious Artemis missions and those beyond. One of those challenges is working with cryogenic fluids, meaning fluids existing in a liquid state between -238 degrees Fahrenheit and absolute zero, -460 Fahrenheit. These fluids, liquid hydrogen, the most difficult to work with, methane, and oxygen, are vital to spacecraft propulsion and life support systems. The fluids may also be produced in the future on the lunar and Martian surfaces via in-situ resource utilization (ISRU). Human exploration in deep space requires storing large amounts of cryogenic fluids for weeks, months, or longer, as well as transferring between spacecraft or fuel depots in orbit and on the surface. Each aspect is challenging, and, to date, large amounts of cryogenic fluids have only been stored for hours in space. Engineers working in NASA's Cryogenic Fluid Management (CFM) portfolio are solving those issues ahead of future missions. This is a task neither NASA nor our partners have ever done before, said Lauren Amin, Deputy CFM Portfolio Manager. Our future mission concepts rely on massive amounts of cryogenic fluids, and we have to figure out how to efficiently use them over long durations. For a cryogenic fluid to be usable, it must remain in a frigid, liquid state. However, the physics of space travel, moving in and out of sunlight and long stays in low gravity, make keeping those fluids in a liquid state and knowing how much is in the tank complicated. Being unsure of how much gas is left in the tank isn't how our explorers want to fly to Mars. Low gravity is challenging because the fuel wants to float around, also known as slosh, which makes accurately gauging the amount of liquid and transferring it very difficult. Previous missions using cryogenic propellants were in space for only a few days due to boil-off or venting losses, Amin said. Those spacecraft used thrust and other maneuvers to apply force to settle propellant tanks and enable fuel transfers. During Artemis, spacecraft will dwell in low gravity for much longer and need to transfer liquid hydrogen in space for the first time. To reduce boil-off, improve gauging, and advance fluid transfer techniques for in-space propulsion, landers, and ISRU, there are 4 near-term efforts taking place on the ground, in near-Earth orbit, and soon on the lunar surface. These are flight demos, radio frequency mass gauge improvements, cryocoolers and cryofill. Ultimately, NASA's efforts to develop and test CFM systems that are energy-mass- and cost-efficient are critical to the success of the agency's ambitious missions to the Moon, Mars, and beyond. Nuclear fusion power was supposed to be a dream come true. As soon as we discovered that you could smash little atoms together to make bigger atoms and release a small amount of energy in the process, scientists around the world realized the implications of this new bit of physics knowledge. Some wanted to turn it into weapons, but others wanted to develop it into a clean, efficient, inexhaustible supply of electrical energy. But it turns out that fusion power is really difficult. Really complicated. Full of unexpected pitfalls and traps. We've been trying to build fusion generators for 3/4 of a century, and we've made a lot of progress, enormous, groundbreaking, horizon-expanding progress. But we're not there yet. Fusion power has been one of those things that's been only 20 years away, for about 50 years now. The primary challenge is that while it's relatively straightforward to make fusion happen, we did it all the time with thermonuclear weapons, it's much more difficult to make the reaction slow and controlled while extracting useful energy from it. In the modern era, there are 2 major approaches to attempting useful nuclear fusion power. One is based on a process called inertial confinement, where you shoot a bunch of lasers at a small target and make it explode, triggering a brief fusion reaction. In December 2022, the Department of Energy's National Ignition Facility made headlines for using this method to achieve break-even, where more energy is released from the fuel than went into it. The other approach is based on magnetic confinement, where powerful magnetic fields squeeze on a plasma until it begins fusing. Experiments here have come a long way but have run into continued struggles in ensuring that the plasma remains stable, which is necessary for a steady fusion reaction. The latest iteration, called ITER, is currently under construction by an international research consortium, which hopes that, when finished, ITER will be the first magnetic confinement device to achieve break-even. But unfortunately, fusion research has been relegated to the same priority as most other lines of research, meaning it will take roughly a century to come to fruition. Japan on Friday successfully launched a rocket with a payload of an intelligence-gathering satellite to improve its abilities to monitor North Korea and natural disasters, as several Asian nations seek to put spy orbitals into space. The H-2A rocket launched from the Tanegashima Space Center located on the southern Tanegashima Island at 1:44 p.m. local time Friday. The rocket flew as planned and confirmed that the intelligence-gathering satellite optical unit 8 was successfully separated, Mitsubishi Heavy Industries, the maker of the H-2A rocket, said in a statement. The launch comes after North Korea officially began its own spy satellite program last year when it claimed to have put one into orbit in November following failed efforts in May and August. It also comes on the heels of China launching its own spy satellite on Tuesday, and South Korea putting its first ever into space early last month. Late last month, North Korea also said it plans to launch more satellites throughout 2024. According to state-run broadcaster NHK, the Japanese satellite is capable of capturing images of anywhere on Earth. Friday's mission was the 48th launch of Japan's H-2A rocket, which first went into operation in 2001. Mitsubishi Heavy Industries has transferred launch service operations from the Japan Aerospace Exploration Agency in 2007, the company said. Japan initiated its reconnaissance satellite program after North Korea launched a Tipo-dong missile over the Asian archipelago country in August of 1998. And you wanted to do this next story, didn't you, Steve?
Well, you can if you want to, Hallie.
Okay, thanks. It looks like the Peregrine mission is headed back to Earth. A private U.S. lunar lander that has been leaking fuel throughout its journey is now headed for Earth and will likely burn up in the atmosphere, the company said Saturday. Astrobotic has been posting regular updates on the Peregrine lander's status since the start of its ill-fated voyage, which began when it blasted off on a brand-new Vulcan rocket built by United Launch Alliance on January 8. Shortly after it separated from the rocket, the spaceship experienced an onboard explosion and it soon became clear it would not make a soft lunar touchdown because of the amount of propellant it was losing. What do you think, Steve?
Well, that loss of fuel doomed Peregrine's chances to soft land on the moon next month, according to Astrobotic. That's the people who built the lander. While the company has been fighting to keep the lander alive as long as possible, a representative of the company said it looks like the probe's days are definitely numbered due to its trajectory. And despite these issues, devastating as they may be, Astrobotic's team was still able to power up the science experiments on board, and they were carrying those for NASA and other space agencies, and they were able to gather spaceflight data, which is of some benefit at least.
Yes, the company representative said, our latest assessment now shows the spacecraft is on a path towards Earth, where it will likely burn up in the Earth's atmosphere, the Pittsburgh-based company posted on X. Although the company didn't post an expected date or time of arrival back on Earth. The team is currently assessing options and will provide updates as soon as they are available. The box-shaped robot has now been in space for more than 5 days and is currently 390,000 kilometers from our planet. Steve, can you convert the kilometers for the American listeners?
Oh, of course, because America still uses the imperial measurements, of course. And for our North American listeners, Hallie, 390,000 kilometres conversion is a distance of 4,265,097 standard American football fields long.
Nice. Space watchers have been following Peregrine's trajectory closely, and many had hoped it might still make a hard landing on the moon, as other failed landers have done before, although it's now clear that even that reduced goal won't be achieved. You know what they mean by hard landing, don't you?
Oh yeah, it's not pretty.
Not at all. You can take it from here, Steve.
Thanks, Hallie. In addition to science hardware, the spaceship is carrying cargo for private clients of Astrobotic, including sports drink can, a physical Bitcoin, as well as human and animal ashes and DNA. Astrobotic is the latest private entity to have failed in a soft landing, following an Israeli non-profit and a Japanese company. NASA had paid Astrobotic more than $100 million for carrying its cargo under an experimental program called Commercial Lunar Payload Services. The overall goal is to seed a commercial lunar economy and reduce its own overheads. Though it hasn't worked out this time, NASA officials have made clear their strategy of more shots on goal means more chances to score, and the next attempt by Houston-based Intuitive Machines launches in February. Astrobotic itself will get another chance in November with its Griffin lander transporting NASA's Viper rover to the lunar South Pole.
Astronomy Daily, the podcast, with Steve Dunkley and Hallie.
Thank you so much, Hallie, for joining me for those stories. Oh, she's giving me a hard time today. Oh, boy. Oh, well. Maybe it's the popularity of AI on social media. She's getting maybe she's getting ideas. Who knows? Anyway. And she won't leave me alone if I don't remind you that you can find all the Astronomy Daily episodes, including the ones where Hallie doesn't give me a hard time, at these places. Just visit bitesz.com, that's bitesz.com, and spacenuts.io. Of course, you can find all the episodes of our parent podcast, which is Space Nuts, featuring Andrew Dunkley and Professor Fred Watson over there as well. Also, if you pop your email into the slot provided, you will receive the Astronomy Daily newsletter as well. And that comes in daily, of course, and you'll have all the latest news about science, space science, and astronomy. And now for something that I found this morning on the Astronomy Daily newsletter, something very interesting about Artemis, one of my favourite things. NASA announced on Tuesday significant updates to its Artemis campaign. These updates aim to lay the groundwork for long-term scientific exploration on the Moon. The program's ambitious goals include the landing of the first woman and the first person of colour on the lunar surface, as well as preparing for human expeditions to Mars, all for the greater good of humanity. To ensure these missions are carried out safely, NASA officials have revised the schedules for Artemis II and Artemis III. This adjustment allows teams to address challenges linked to the first-time developments, operations and integration. Artemis II, the first crewed mission, is now slated for September 2025. It will orbit the Moon. Artemis III, planned for a September 2026 launch, aims to land astronauts near the lunar South Pole. Artemis IV, the first mission to Gateway, the lunar space station, remains on track for 2028. We are returning to the Moon in a way we have never before, and the safety of our astronauts is NASA's top priority as we prepare for future Artemis missions, said NASA's Administrator Bill Nelson. We've learned a lot since Artemis I, and the success of these early missions relies on our commercial and international partnerships to further our reach and understanding of humanity's place in our solar system. Artemis represents what we can accomplish as a nation and as a global coalition. And when we set our sights on what is hard, together we can achieve what is great. Good words. Ensuring crew safety is the primary driver for the Artemis II schedule changes. As the first Artemis flight test with crew aboard the Orion spacecraft, the mission will set critical environmental control and life support systems required to support astronauts. NASA's testing to qualify components to keep the crew safe and ensure mission success has uncovered issues that require additional time to resolve. Teams are troubleshooting a battery issue and addressing challenges with circuitry component responsible for air ventilation and temperature control. NASA's investigation into unexpected loss of char layer pieces from the spacecraft's heat shield during Artemis I is expected to conclude this spring. Teams have taken a methodical approach to understand the issue, including extensive sampling of the heat shield, testing and review of data from sensors and imagery. The new timeline for Artemis III aligns with the updated schedule for Artemis II, ensures the agency can incorporate lessons learned from Artemis II into the next mission, and acknowledges development changes experienced by NASA's industry partners. As each new Artemis mission increases complexity and adds flight tests for new systems, the adjusted schedule will give the providers developing new capabilities, SpaceX for the Human Landing System and Axiom Space for the next-generation spacesuits, additional time for testing and any refinements ahead of the mission. We are letting the hardware talk to us so that crew safety drives our decision-making. We will use the Artemis II flight test and each flight that follows to reduce risk for future moon missions, said Catherine Cohner, Associate Administrator, Exploration Systems Development Mission Directorate at NASA headquarters in Washington. We are resolving challenges associated with first-time capabilities and operations, and we are closer than ever to establishing sustained exploration of the Earth's nearest neighbour under Artemis, she said. In addition to the scheduled updates for Artemis II and III, NASA is reviewing the schedule for launching the first integrated elements of Gateway, previously planned for October 2025, to provide additional development time and better align that launch with Artemis IV mission in 2028. NASA also shared that it has asked both Artemis human landing systems providers SpaceX and Blue Origin to begin applying knowledge gained in developing their systems as part of their existing contracts toward future variations to potentially deliver large cargo on later missions. Artemis is a long-term exploration campaign to conduct science at the Moon with astronauts and prepare for future human missions to Mars. That means we must get it right as we develop and fly our foundational systems so that we can safely carry out these missions, said Amit Kshatriya, who is the Deputy Associate Administrator of Exploration Systems Development and Manager of NASA's Moon to Mars Program Office at headquarters. Crew safety is and will remain our number one priority. NASA leaders emphasise the importance of all partners delivering on time so that agency can maximise the flight objectives with available hardware on a given mission. NASA regularly assesses progress and timelines, and as a part of integrated programmatic planning to ensure the agency and its partners can successfully accomplish its Moon to Mars exploration goals. With Artemis, NASA will explore more of the Moon than ever before, learn how to live and work away from home, and prepare for human exploration of the Red Planet. NASA's SLS, that's the Space Launch System rocket, Exploration Ground Systems and Orion spacecraft, along with the Human Landing System, Next Generation Spacesuits, Gateway Lunar Space Station, and future rovers are NASA's foundation for deep space exploration. And just like that, there was no more. Thanks for sticking with us today. We'll be back again next Monday. And of course, you can sit in with our pal Tim Gibbs all the way from Bath in the beautiful Somerset, England for Friday's session, who will have another collection of fascinating stories from the Astronomy Daily newsletter. Go get yours at those addresses that I gave you earlier on in the episode. And that's all from me, Steve Dunkley, your host, and we'll see you later.
And see you later from me.
Bye, Hallie.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.